Last week I designed the user interface for the Godot port of my Twine project, Zeitgeist 1980. I wouldn't call this design final, particularly the colors, but all of the elements are present and in place. This week, I've been implementing the Godot interpreter for Inkl's Ink script using Efred's Ink GD plugin. I'd done something similar in Unity a year before for the Adventurer demo using the official Ink Unity implementation. Adventurer was only ever going to be a tech demo though. Any actual game will need a wrapper custom made for that game. Essentially, the Ink plugin does all the heavy lifting of interpreting the Ink files, outputting the story data and choices to the Godot layer. In turn, the choices made when the player clicks on the Godot buttons is input back into the Ink interpreter to find the next story passage. And that's basically all there is to it. There are basically two ways I could have gone about this. Back when I did the Adventurer demo in Unity, I basically just took the text and plugged it right into a static game text object, and I did the same thing for the choice buttons from the different game options you had. Just plug the text right in there. This worked fine, but it meant that players couldn't go back and read prior sections of text once they made a new choice, because it's not really stored by either the engine or the wrapper that I made. The Godot interpreter started the same way, but I quickly decided that I'd rather give the player the option to scroll back up and read prior text sections. Godot provides a scroll container that implements a UI scroll bar for you, making this fairly easy. So instead of just plugging text in from the story data as it arrives, I implemented new section of text nodes stacked under what's currently available, and it forces the scroll bar down to its maximum depth. I also took a moment to add in some code to modulate the alpha of all previous implemented text nodes to make it clearer for the player what the new text is. I do something similar for the choice buttons. In Unity, I simply plugged in choice data to static buttons which were deactivated when not in use, but in Godot, I just instance new buttons as they're needed and delete the old ones when they're done. One big factor in how this was implemented is Godot's HBox and VBox containers, which automatically stack and arrange their content into, neat rows or columns. As I mentioned last time, once I got the text and buttons working, I technically had a minimum viable project ready to go. I played with it a bit, made sure that it felt right, that the text box was big enough, and that I hadn't screwed anything up. I did. I screwed up a lot. But I managed to fix it. This time. Mostly. Implementing the player badges comes next. At the beginning of the game, there's a character creation sequence where you're sorted into an 80s archetype like jock, nerd, skater, goth, whatever. But rather than just give the player a class, they get traits that the game tests for to see what you're capable of. Preppies get rich kid, nerds get smart, losers get unlucky, and so forth. I'll talk about how these are used in the gameplay when I discuss the Ink port in my next video. For now, know that to let the player see and interact with them, they had to also exist in the Godot layer. Fortunately, the Ink runner offers 3 methods to pull data out of the Ink layer. First, you can use tags, and that's what I did at first. You include a tag in the game text, and you can test for it at the point where the next section of the story is read and make the interpreter do things. Secondly, you can make direct calls from Ink to external functions, though it's generally recommended that you not make game state changes because these functions can get called at unexpected times. Third, and the method I use for the badges, you can have Godot observe certain Ink variables and send a signal when they change. So, for traits, what I did was set up the observer function to watch each of the trait variables. When one changes, it sends a signal to the UI layer. I put 3 containers to the top of the screen, one for the save, load, and quit buttons, one for traits, and one for conditions, which will, for our purposes, be implemented exactly the same way. So when a trait or condition is changed, it clears the trait container, then implements each trait's badge icon, filling the row with whatever traits are on, or possessed by the player. The badge objects, what you'd call scenes in Unity or nodes in Godot, are simply the graphical icon with a tooltip that tells you what the badge is if you hover over it. For now I'm using placeholders from gameicons.net, but I may replace these in the final release. Back to story structure for a bit. After getting some good advice in the Inkle Discord, I decided to go with individual Ink files for each chapter of the game. This will make it easier for me to add new DLC chapters as I finish storylines. It's not difficult to load a new Ink story into the runner, but I needed functions to copy any data that I wanted over to the new story. This took 2 steps. First, exporting character traits and any persistent flags to the Godot layer, then creating an import tag function to load them back in when a new story starts. I also used this function to clean up any old text passages from the last story just to keep things tidy. I'll have to update this process as new traits or flags are added, but I don't have to know what they are in advance, and that's good, because I haven't planned that far in advance. I have a vague idea of where I'm going with this. I have a very, very sparse outline, but as to what happens in each chapter, I'm kind of coming up with that as I'm working on that chapter. Now, Ink has a built-in save state for the story itself, but that doesn't include any data I have not run in the Godot layer. I can reread in the character traits with a simple call to the trait update function, but for the actual save file, I'll need to structure the data a bit. First, I save a reference to the current Ink file so the correct story is loaded when we come back. Then I save the Ink story state as a JSON using the built-in function. This preserves the choices we make to get to the current Ink game state, so if we change our Ink file before we load, it'll break the save. Now, I save a dictionary of the player data we have saved in the Godot layer. Traits, conditions, flags, archetype names, etc. Loading works the same way, reading it all back from the same file into the Godot layer, and then loading the Ink state. After showing the current state of the project to an alpha tester, they found it difficult to differentiate the new text from the old text. Social media had trained them to look at the top of the feed when new text suddenly appeared in a jump cut. I had 3 ideas to deal with this. 1, a simple text log modal. 2, animating the scrolling as new text was added. 3, pagination, allowing the player to pop back to earlier passages in the game window. Of the 3 options, the log modal was easiest to implement, so that's what we're going with for now. I might implement pages or scrolling in the future, but for now the goal is quick implementation. I'm leaving out a lot of trial and error where I implemented things the wrong way, but that's basically it. Other than a few splash screens where we load a new story or ask the player to input their name. The Ink runner will keep growing and evolving as the Ink story asks more of it, but we have a solid foundation. Next devlog I'm going to discuss more of the process of porting Zeitgeist from Twine to Ink. I've been doing it a bit this week just to have the content necessary that I could work on the runner and its issues. I do need to refine the runner, but now that it's minimally implemented, I could focus on getting story working. As always, ask any questions or make suggestions in the video comments, and subscribe to the channel if you want to follow along with the rest of the Zeitgeist 1980 development.